Okay, let's look at part 2. I'm starting here with question number 7. Find the duration of a 4-year annual pay bond with a coupon rate of 6%. So first I need, let's call this the time. We have time 1, 2, 3, 4 years. I'm always going to do duration assuming annual pay bonds, just to make it easier. I mean, bonds are still semi-annual pay usually, so you'd have to do it semi-annually, but this makes the calculations a little easier to deal with. So just a simplification. 6% coupon means to pay 60, 60, 60, 1,060. Next you need to find the present value of those cash flows. 60 divided by, and your yield to maturity is 6.2%, so that's divided by 1.062 to the first. This is 60 divided by 1.062 squared. 60 divided by 1.062 cubed. 1060 divided by 1.062 to the fourth. And let me pause and write some numbers down. Okay, so now when I add this up, the price of this bond is $993.10. You can also find that by putting in your calculator n equals 4, payment equals 60, future value is 1,000, IY is 6.2. So this is equal to 56.50. This is equal to 53.20. This is equal to 50.09. This is equal to 833.31. Next I want to find the weights. So I want to take each number, the 56 over the price, the 993, that's 0.0569. The 53 over the 993 is 0.0536. The 50 over the 993 is 0.0504. And then the last one, the 833 over the 993 is 0.8391. I have beautiful handwriting, don't I? So that adds up to 1. The last column is weight times time. So this is 0.0569. This times 1. This happens in time 2, so that times 2 is 0.1071. This happens in times 3, so that times 3 is 0.1513. And then this happens in time 4, so that's 3.3564. Add that up, and that's 3.6718. I think on the answer key I mailed out, I couldn't read and I missed my 1 there. Why is that important? This gives me an approximation to the change in the price. So if I have a huge bond portfolio, well, just one, I just found a new price. But if I have this tells me how sensitive my bond price is to interest rates. If I think rates are going up, I want to get my bond portfolio with a low duration. If I think rates are going down, I want a long duration. The change in the price of my bond is going to be approximately, so the squiggly equal sign, approximately equal to minus D star times delta Y times P. D star is modified duration, which is 3.6718. This is always represented as D. Macaulay duration, or just called duration. Modified duration is that divided by 1 plus the yield to maturity, which is 6.2%. So the change in the price is equal to minus 3.6718 divided by 1.062 times, it says the yield went up, right? The yield went up, so it increased by 20 basis points, which is 0.002. So that's 20 basis points. Keep up with the signs here. This is negative. Rates went up, that was positive. If rates have gone down, that would be negative. And negative times a negative would be positive, right? So if rates go up, bond prices go down. That's why you have the negative there. and multiply by the price, 993.10. So the new price is equal to the change in price plus the old price, and that's going to be equal to 986.23. Okay, so let's get rid of this. Now, number 9. So that was 7 and 8 together. Number 9, you have a 5-year GIC. Okay, GICs are zero coupon bonds. You give some money to an insurance company today, the guaranteed investment contract. I come back in 5 years and I get some amount of money. The example we used in class, you pay $1,000 today, and then in 5 years you get $1,469.32. So I'm promising you an investment of something like that. So a GIC has a duration of the time to maturity. I want the duration of my assets to equal to the duration of my liabilities. So if I am the insurance company who sold the GIC, that's my liability. I have to pay that back to the investor. That duration is 5 years. I take the proceeds from selling that GIC, and in our simple economy we have 2 bonds. Bond A has a duration of 4 years. The duration of a portfolio of bonds is equal to the sum of the weights. So in other words, the duration of my portfolio of 2 bonds is equal to the weight in bond A times the duration of bond A plus the weight in bond B times the duration in bond B. I also know the weight I put in A plus the weight I put in B has to equal 100% of my weight. So the duration of my liabilities is 5. I can put some money in a bond A that has a duration of 4 years plus some money in bond B that has a duration of 5.8 years. So 5 is equal to 4 times 1 minus the weight of B plus 5.8 weight of B, making this substitution right here from this equation. So 5 is equal to 4 minus 4 weight of B plus 5.8 weight of B. 1 is equal to 1.8 weight of B. 1 over 1.8 equals the weight in B. So the weight in B is equal to 55.56, rounding off percent, which means the weight in A is equal to 44.44%. 10. A stock pays a dividend today of $2.50. Write down what you know. Dividend today, D0, $2.50. Assume a discount rate of 14%. Write down what you know. K is equal to 14%. Constant growth. My best words I can ever read when I'm doing stock pricing. Constant growth of 5%. The price today is equal to D. I don't have D1, but D1 is equal to D0 times 1 plus G. Is equal to D1 over K minus G, which is equal to, my contacts are messing up, I hope I can read this right, 29.17. 11 looks a lot like it. I wanted to show you the one difference. 11, a stock will pay a dividend next year. Write down what you know. D1 is equal to $2.50. Discount rate of 14%. Growth rate, constant growth, wonderful, 5%. This is the easiest problem I can get. D1, I already have it, 250 over K, I already have it, minus G, I already have it, is equal to 27.78. Alright, on to number 12. The stock will pay a dividend of $2.50 next year. No, today. Number 12, D0, 250. Discount rate of 14%. Great K is equal to 14%. Dividends will grow at 25% for the next 4 years, and this is, oh man, why do they have to grow? So this makes it long. So now I know, because it's going to grow for 4 years, P0 is equal to D1 over 1.14 plus D2 over 1.14 squared plus D3 over 1.14 cubed plus D4 over 1.14 to the fourth plus P4 over 1.14 to the fourth. What's the rule of pricing any financial asset? It's the present value of the expected future cash flows. So I need the present value of all the future dividends. Well, let's see what I have. Here's the present value of D1, the present value of D2, the present value of D3, present value of D4. I got it. What about D5 and forward? Well, P4, the price in year 4 is equal to the dividend in year 5 divided by K minus the long-term growth rate, which in this case was told to be 5%. So this number, whatever this number comes out to be, is the value of dividend 5 and forward as of year 4. So if I take the present value of P4, that gives, the value today of P4, that gives me the value of all the dividends, right? Because P4 is the value of all the dividends as of year 4. Take that amount back to year 0 by dividing by 1.14 to the fourth, and we got it. So now, all we have to do is find the numerators. D1 is $2.50 times the growth rate is 25% times 1.25. D2 is equal to whatever you got for D1 times 1.25. D3 is equal to whatever you got for D2 times 1.25. And D4 is equal to whatever you got for D3 times 1.25. Well, what's P4 equal to? P4 is equal to D5, which is wherever you got for D4, times, now it's slowing down, the growth is now 5% divided by 0.14 minus 0.05. Plug all those numbers in, and that's 47.49. Okay, number 13. What is, oh, that's an ugly color. What's the fastest or the highest long-term growth can be? It's going to be nominal GDP, which is equal to real GDP plus inflation. So I don't care if you tell me nominal GDP or real GDP plus inflation, it's all the same. Alright, in the home stretch now. We got 13 taken care of. 14. What is the H model? Well, basically what we've assumed is something like this. This is time, and this is your growth rate. We've said in the past the growth rate does this. It stays up really high for some number of years, and then all of a sudden it drops down to something really low. It seems just crazy. There's no way, we're saying this is going to be, like in the last problem, it's 25% for 4 years and then it goes down to 5%. People looked at that and said that doesn't really make sense. I don't think that's how it really works. So what I think probably really happens is it grows really fast for some number of years, and then it slows down gradually and then levels off. So we're not going to do any numbers with it because it's not in your book, but that's what the H model is. It just says we start out with this high growth for some number of years, and over that same time period, if it takes 4 years of high growth, over the next 4 years it's going to gradually descend to the long-term or steady state growth of 5%. Okay, number 15. What must be true for you to be able to use the dividend discount model? DDM is the dividend discount model. 1, has to pay dividends, obviously. 2, the dividend policy has to reflect the profitability of the firm. So I can't be paying a penny dividend or a 2-cent dividend just to say I'm paying a dividend. It's actually reflect the profitability of the firm. And 3, I'm not talking about taking control. I'm not Warren Buffett buying the whole company out where I can then change the dividend policy. I'm just buying a few shares of it. 16, define free cash flow to firm and free cash flow to equity. All I want you to know is the equation in your book, and that the next step that we're not going to get to, but the next step is most firms you don't use the dividend discount model because most firms these 3 things don't apply, so you need something else that's a free cash flow model of some sort.